Hey everyone and welcome back to the channel. Today we're going on a mini flight adventure. Forget about complicated kits or expensive drones. We're going to build something amazing with just a few simple things you probably have lying around the house right now. Get ready to make your very own straw helicopter. That's right, with just a piece of paper, a drinking straw, and a little bit of tape, we're going to unlock the secrets of flight. This is going to be so much fun, and you'll be surprised at how well these little guys can fly. So grab your materials and let's get ready for takeoff. First things first, let's gather our supplies. It's super simple. You'll need one standard drinking straw. Any kind will do, plastic or paper, but a slightly sturdier plastic one might be easier to work with. Next, you need a piece of paper. Regular printer paper is perfect for this. You'll also want some scissors to do the cutting and a roll of clear tape. A ruler is also handy to have to make your measurements precise, but you can totally eyeball it if you want. That's it. See, I told you it was easy. Once you have everything ready, find a clear space on a table or desk, and we can start building our flying machine. Okay, let's build the main rotor, which is the part that will spin and create lift. Take your piece of paper and your ruler. We're going to cut a rectangle that is about 1 inch wide and 8 inches long. Precision isn't super critical here, so don't worry if it's not perfect. Once you have your paper strip, fold it exactly in half to create a crease right in the middle, then unfold it. Now grab your scissors. You're going to cut along that center crease, but stop about ½ inch from the end. You want to leave a small, uncut section at the top that holds the two sides together. This little uncut part is really important because it will be the hub of our rotor. Now, let's turn this flat piece of paper into a propeller. Take one of the flaps you just cut and fold it down at a 90-degree angle. Do the same for the other flap, but fold it in the opposite direction. Imagine you're making a tiny, two-bladed fan. When you look at it from the top, the blades should be pointing in opposite directions, creating a nice flat T-shape. This is what will catch the air as it falls, causing the helicopter to spin. Make sure your folds are crisp and sharp. The better the fold, the better the spin. This is the magic behind our helicopter's flight. Next up, we need to attach our rotor to the helicopter's body, which is our straw. Take your drinking straw and hold it upright. Now, carefully place the center hub of your paper rotor right on top of the straw. The part you didn't cut should sit flat against the opening of the straw. Now, grab a small piece of tape. You're going to use this to secure the paper rotor to the top of the straw. Try to get the tape on as smoothly as you can and make sure the rotor is centered. If it's off to one side, your helicopter might be wobbly. A single piece of tape wrapped around the top should be enough to hold it firmly in place. Our helicopter needs a little bit of weight at the bottom to stay stable while it flies. This is called ballast. Without it, our helicopter would just tumble and flip over instead of gliding down smoothly. We're going to add some weight using paper clips. Take two standard paper clips and slide them onto the bottom end of the straw. This added weight lowers the helicopter's center of gravity, making it more stable and helping it fly straight down instead of just fluttering randomly. It's a tiny detail, but it makes a huge difference in performance. Your straw helicopter is now officially complete. Simple, right? Alright, the moment of truth has arrived. It's time for our first test flight. For this, you'll want to find a spot with a high ceiling or, even better, go outside on a calm day with no wind. Stand on a chair or at the top of some stairs to give your helicopter plenty of room to fall. Hold your helicopter by the straw with the rotor at the top. Hold it up as high as you can and then simply let it go. Don't throw it up or push it down, just release it. Watch as it falls. As it picks up speed, the air pushing up against the folded blades will cause the rotor to spin. The spinning motion creates lift and slows its descent, making it glide gracefully to the ground. Isn't that amazing? So, what's the science behind this? It's all about basic aerodynamics. When you drop the helicopter, gravity pulls it downward. As it moves through the air pushes up on the angled rotor blades. Because the blades are angled in opposite directions, this upward push of air forces them to start spinning. This spinning motion is key. The rotating blades act like a wing, generating a force called lift. This lift pushes upward, opposing gravity and slowing the helicopter's fall. The heavier paper clips at the bottom provide stability, keeping the helicopter upright. You've just witnessed gravity, air resistance, and lift all working together in perfect harmony. Now comes the really fun part, experimentation. This is where you become a real engineer. What happens if you change the design? Try making the rotor blades wider or narrower. Does a wider blade create more lift and a slower fall? What if you make the blades longer or shorter? How does that affect the spin speed? Try using a different kind of paper, like cardstock, which is heavier, or tissue paper, which is lighter. Does the weight of the paper make a difference? You can also experiment with the number of paper clips at the bottom. What happens if you add 3 or 4? Or what if you use only 1? Let's push the experimentation even further. What if you change the angle of the rotor blades? Instead of a sharp 90-degree fold, try a gentler 45-degree angle. Does that make it spin faster or slower? You can also try making a helicopter with 4 blades instead of 2. Just cut to paper strips, lay them on top of each other in a cross shape, and tape them together in the middle before attaching them to the straw. How does a 4-bladed helicopter fly compared to a 2-bladed one? Every single change you make will affect how your helicopter flies. Keep a little notebook and jot down your observations. This is exactly how real aircraft designers work, by testing, observing, and improving their designs over and over again. Let's do one more fun variation together. How about a dual-rotor helicopter? For this, you'll need a longer straw, or you can tape 2 straws together. Build 2 separate rotor systems just like we did before. Attach one at the very top of the long straw. Then attach the second one a few inches below the first one. Here's the trick. Make sure the blades of the bottom rotor are angled in the opposite direction to the blades of the top rotor. When you drop this one, you should see the 2 rotors spinning in opposite directions. This design can be incredibly stable. Have a competition with your friends or family. See who can design a helicopter that stays in the air the longest. You can set up a landing pad on the floor and see whose helicopter can land the closest to the target. The possibilities are endless. This simple toy is a fantastic way to understand some really big ideas in physics and engineering. The principles of lift and drag that make your straw helicopter spin are the exact same principles that allow real helicopters and airplanes to fly. The process of testing and modifying your design is the core of the engineering design process. So the next time you see a helicopter in the sky, or even a maple seed spinning its way to the ground, you'll have a much better understanding of the amazing forces at play. I hope you had a blast making your straw helicopter today. Keep experimenting, keep asking questions, and never stop exploring the world around you. Thank you so much for building and flying with me today. I hope you enjoyed this project as much as I did. If you did, please give this video a thumbs up, and don't forget to subscribe to the channel for more fun and easy science experiments you can do at home. I'd love to see your creations. Share photos or videos of your helicopters in action and tag us on social media. Let me know in the comments below what designs worked best for you and what other experiments we should try next. Thanks again for watching, and I'll see you in the next video. Bye.